जस्ट इमेजिन तुम्हारी कंट्रोल से कंट्रोल भी करने की बहुत बुरी आदत है, एंड फॉर श्योर आफ्टर चैट जीपीटी एरा सबकी बुरी आदत पड़ गई है, बट कैन यू बिलीव किसी ने कंट्रोल से कंट्रोल भी मारा एंड उसकी वजह से कंपनी का $370 मिलियन का नुकसान हुआ। एंड यही नहीं, 10 साल की मेहनत पानी में बर्बाद, just because of one thing, that person, that software developer did not take into consideration कि जो उसने कॉपी पेस्ट किया है कोड, उससे आ सकती है एक चीज, इंटीजर ओवरफ्लो, जो कि बहुत नॉर्मल है, हमने देखी होगी, बट he did not think of that part, and उसकी वजह से $370 मिलियन was gone। तो ये सब हुआ था 1996 में। यूरोपियन स्पेस एजेंसी ने अपना रॉकेट लॉन्च किया एरियन 5। अब उन्होंने पहले लॉन्च कर रखा था एरियन 4, उसका एक सक्सेसर था एरियन 5। अब इसकी खासियत ये थी कि ये बनाया गया था बहुत ही एक्सपेंसिव, लार्ज, साइंटिफिक एंड कॉस्टली कमर्शियल पेलोड को स्पेस में भेजने के लिए। एंड जैसे तुमने सुन लिया, इसका कॉस्ट पड़ा था $370 मिलियन, और प्रॉपरली 10 साल की डिजाइन टेस्टिंग के बाद ये रॉकेट लॉन्च किया जा रहा था 1996 में। अब अच्छी बात इसमें ये थी कि इसमें कोई इंसान नहीं था, इट वाज अ रॉकेट व्हिच वाज टेकिंग अ पेलोड, वेरी हाईली एक्सपेंसिव साइंटिफिक पेलोड, जो कि ऑर्बिट में डिलीवर करना था उन लोगों को। अब ये रॉकेट अपने लॉन्च पैड से निकलते ही ओके, ही वाज गोइंग प्रॉपर्ली इन इट्स डायरेक्शन, इन इट्स ट्रेजेक्टरी, बट कुछ देर चलते ही थोड़ा सा डगमगाया, टेढ़ा हुआ और फिर फटने लगा और एकदम से ब्लास्ट हो गया। 1 मिनट के अंदर पैसे गए, 10 साल की मेहनत गई। अब let's take a step back and come and see कि actually में हुआ क्या। So our thing starts pretty good. Ariane 5 rocket, it leaves the launch pad and started to accelerate. But as it keeps on accelerating, what happens internally is the onboard guiding system, which tells him what's the velocity, direction, all that stuff, it sends the information to our main flight computer, which tells him, bro, if your direction is this, you have to go in this direction. If your direction is this, you should be in this specific speed. So this is what the main flight computer handles the entire navigation of my rocket. Now, they are just computers which communicate with each other. So the main work of guiding system is to know the trajectory of the rocket and to compute velocities and all other parameters which the rocket need to have. So what it does is, it has a velocity which you can see will be in a floating value, and we know the floating values are 64-bit floating values, but as the velocity was very low, so they used to convert it to a 16-bit integer and then pass it to the main flight computer. But before that, you should know how these floating values and integer values work, which means how our computers store the numbers. So if you have a simple decimal form, let's say 0, 1, 2, up till so on so forth 15. Let's say you just have 4 bits and you have to represent these integers from 0 to 15. Then you can simply say 0, 0, 0 will be a 0, 1, 1, 1 will be a 1. But as soon as you try and want to make a number 15, then you will see that these 4 bits are not enough. You need to have 5 bits to represent the number, and that is what called as an integer overflow. If the bits cannot fit a upcoming number, then as soon as I will write a 16 in a 4-bit integer, it will go and round off and will become a low value. So same way our other decimal numbers, which are big numbers, work the same way. If I have to say that minus 32768 up till 32767, I can represent as a 16-bit integer like this form. But as soon as I will go and try to increase the number, let's say if I want to make a 32768, then it will not be able to do it, and then it will actually round off to the next bit, and this is what is called as an integer overflow. Now coming on back, that we had a floating value, so we should also be knowing that how to represent that floating value to the bits. So for sure a floating value will have a sign. For that sign I have 1 bit attached. For the next power I have 11 bits attached, and for the actual main value I have 52 bits for it. So now you know that okay, actually a floating value needs 64-bit, but what I was doing was I was converting that velocity which was of 64 bits to a 16-bit integer, which I thought of was sufficient, more than sufficient for a rocket to have velocity. But that was an issue. What was the issue? Because of the 64-bit floating point value, I was converting to a 16-bit integer. This conversion can be very tricky, and that's what caused us integer overflow. What happened ultimately was this guidance system It tries to find the value, the velocity right now, it was very high. It tried to convert that to integer, it wasn't able to convert it. Now, if he isn't able to convert it, he will simply do a round off. He will be able to convert it, he will round off it and simply give that rounded off value. But he should have thrown the error, which he did not throw the error. Now, this round off value went on to my main flight computer and he thought of, okay, velocity was high, it has decreased. If the velocity is decreased, for sure, the rocket cannot go above. If the velocity is decreased, rocket cannot go above. So rocket needs to be like a plane. It needs to be a bit slanted. So at a very high speed, he thought of the rocket should be slanted, but rocket actually needs to be straight itself. So this main computer, a main flight computer, tried to make rocket slanted, and thus, if he wanted to make the rocket slanted, the drive was a lot. And because of that reason, what happened was rocket blasted. So if we look very closely, the rocket was going straight, but then the main flight computer wanted it to slant because he thought of speed is slow. So he tried to slant it, but slanting at a very high speed, which means rocket is moving like this, which is very high. So rocket went on tearing apart itself, and then it tore apart, and ultimately the rockets have a self-destruct mechanism because we cannot afford a rocket to land onto any state or any territory if it is entirely packed. So we want, if something fails abruptly, he should do a self-destruct ASAP. And that's what happened. It did a self-destruct and it was finished. Now you will say, Aryan, why was the copy paste done in the first place? Didn't they know about the integer flow? Bro, they did not. So the copy paste was done from Ariane 4 to Ariane 5. The Ariane 4 was the actual rocket which was successful. The Ariane 5 was the upcoming successor of Ariane 4. So they copy pasted the piece of code from the Ariane 4 to Ariane 5, and that's what caused an issue. And the funny part is, this copy paste was not even required, and the code which was running until the last minute, that was also not required, because that code was the launchpad alignment process code. It was not needed for the rocket to itself run, and ideally it should not be running itself in the first place. But what happened was that this alignment process got a bit delayed because of some glitch happening. Thus the programmers, being smart, they thought of, okay, ऐसा करते हैं कि हम इस प्रोसेस को रन होने देते हैं. तो वो जो प्रोग्राम था, उन्होंने वो रन होने दिया बिकॉज उन्हें लगा था कि यार फिर से होता डिले, तो इतना डिले बार बार रीसेट करना पड़ेगा ऑल दैट स्टफ. सो दे थॉट ऑफ, ओके, लेट्स लीव इट, लेट्स कीप ऑन रनिंग इट, एंड दे प्लान टू रन द प्रोग्राम फॉर नेक्स्ट 40 seconds, and the rocket blasted at 39 seconds. So now you know, if you copy paste very carefully and understand what is the functional requirements, and then cheers.